So we got this far last time, right? If you don't have this or you weren't here last class, you can get it from the website. It's under week 4. So download it from there. I think I uploaded this. I might have only uploaded the candy, but I'm pretty sure I put this up there. If it's not, let me know. Okay, so what do we have left to do? So far we have these wheels spinning and they stop. And the first one stops first and the second one stops second. This third one stops third. And then we added some randomness to it so that they don't always stop in the same place. And right now, there's no method of like resetting everything and starting over. So the clock just keeps going. And eventually that counter, actually mine says 600, but I think we all had 1200 on here before. And eventually that clock will roll over and start all over again. So what we want to do, first of all, is we want to stop that clock when the game is over, because we don't want it to roll over. And we want it to reset the clock back to 0 when we spin the wheel the next time. So the first thing to do to stop this clock, we can add something on. Well, what's the last thing that triggers? How does our last wheel stop? That's the last thing that happens, right? Where we want the clock to stop is when the last wheel stops, right? So we can simply just take the output of this logic operator here to also stop the wheel, right? Right now it's simply closing a gate, but we can also use it to stop the wheel. And let's see, how did I do that before? Yeah, that works. Okay. So, right, this is already creating a 1 or a 0 with this toggle, so we can just use the same 0 to stop the metro, right? Because a 1 or a 0 starts or stops the metro. So let's use some sends and receives so we can minimize how many patch cords are going everywhere. And let's call this send clock underscore stop. Here, I'll zoom in a little bit. Okay, so we can pass the output of this toggle here to the clock stop send. Okay, and then we can duplicate this, which is the easiest way to make a receive, and it ensures that you don't spell it wrong, which would break it. And just change the S to an R. So option drag or command D or control copy and control paste. Either way, any one of those will duplicate an object. All right, so then we can take this and pass it to the metro over here for clock stop. And that, look at that, it just stopped. So clicking 0 here on the counter starts everything up. And then as soon as the last one stops, everything stops. Is that working correctly? Let's see. Yeah. Seems to be going faster than it used to, though. Let's see. Why is it going faster? Oh, I know why. I know why. It is going faster because the metro is turning on and off and on and off and on and off. Because this is being sent a 1 or a 0 every single time anything changes. We need to put a change object in here. Which a change object, have we looked at this? I think we looked at this last week. Did we not? All right, we probably did. I guess we didn't. So a change object will only output the number if it changes. Because every time we put a number into this logic operator, this less than or equal to object, it's going to evaluate that. So if it's true, it'll be sending out a 1 every single time. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And if it's a 0, it'll be sending out a 0 every time, when we only need that number once, right? So that 1 was probably spamming this toggle, which was sending its 1 back to the QMetro, which was starting over the QMetro 100 times a second, which is making the QMetro fire faster than it normally would, because it's like the first beat faster than it normally would go by itself. Does that make sense? So the change should fix that. Let's try it. Pass it through the change into the clock stop, and go ahead and trigger this 0, and everything starts. Now it's going the speed that we'd expect. Stops, stops, and stops. So the cool thing about this, we don't have to worry about starting the clock, because as soon as we send a 0 to this counter, this becomes true and starts the clock for us, right? Right? Because as soon as I hit 0, this becomes a 1. See that? And so that gets sent to the sent up here and starts the clock. So now that we've done that clock stopper, we have a system that stops the clock and resets everything right here just by hitting this 0. So we can attach this to a button and call that spin or something, right? New game maybe. So let's see. Just make a message called spin. Wait, that's not going to work. You got to have a button between that. If I pass one message into another message, it will replace that message's contents. So we don't want that. So we could make this really big, and this could be our interface object. There's some better buttons out there. Actually, let's look at one. Text button is a lot prettier button. So this, you got to go into the inspector to change what it says. So Command I to open the inspector. And then you can go down here to find where it says button. There it is, text off label. And we can change this to spin or new game. Let's say new game. Oh, text off label. Okay. So I believe one of these outputs, let's hover over and what do they say? This one is bang when the mouse is up. This one is the symbol. We don't need the symbol. And idle mouse, where your mouse is on the button, we don't need that. So we just need the bang. So like that. Now we click this and you get a new game. All right, we can, let's see. So that is, we're getting there. We need to do, let's see. Let's look at our list here of functions. Which ones have we completed? We haven't done money yet. We've done push the handle. That's done. We've done wheels spin. We've done wheels stop one at a time. We need to do win lose. We haven't done that. We haven't done the payout yet. So let's start with, let's leave money till later. Let's start with the win lose. Great. So, anybody want to guess? Or actually here, let's first of all, what is a winning condition in a slot machine? What's your main winning condition? Exactly, they're all the same. So what could we use to determine if all the numbers are the same? We've been using a similar object. They were called, what were they called? They start with an L, logic operator. So what do you think, what's the logic operator for things being equal? Equals, yeah, equals actually. 2 equals. There's another object called a single equals, which is, no, they got rid of that, which was a bitwise operator, but I guess they got rid of that. Nobody used it anyway. Yeah, it's always equals. And this only wants to compare two numbers, but if you're using equality, then you could, if A is equal to B and B is equal to C, we already know that A is equal to C. We don't need to test that, right? So all we need to do is say, is this one equal to this one? And is this one equal to this one? And then if they are both equal, then we should have a value of 2 if we add these together. So we can use this addition object to chain these logic operators together and create a condition. The condition that they're both, that these two are true and these two are true. So if those equal 2, so we can say select for 2, then that means all the same win. So let's just hack this slot machine to test this out, so we don't have to wait for randomness to make us win. And set this to 1, set this to 1, and set this to 1. And did it bang? I don't think it did. What happened there? Let's see. What we should do actually is take a message and take the output of this plus object and put it into the message so we can actually see what the result is. And go ahead, let's set these to the same. 1, 1, 1. Yeah, so that came out. Why did that only come out as 1? Probably because of order of operations, because this one got done second and didn't get added to what we're adding it to, so it probably added 0 to 1 and never triggered a second time. Let's see, what did I do before to do that? Oh, that's what I did before. I just changed which one triggers the calculation. Like this. So the plus object, it wants to, only one of the inputs will trigger the calculation. If you hover over it, it says this one sets the left-hand operand and triggers the calculation. So we know that the third wheel is always going to come in, is always going to stop last. And so we know that will always be the last thing triggered. We also know that these equals actually work the same way as the plus, in that this first inlet triggers the calculation. So this is wrong as well. Sorry, I just am noticing this on my notes. So switch those around. And we probably should do the same over here, because we want this to set the right-hand operand before it evaluates whether it's true, right? We need to set that this is the first wheel's value. Then when the second wheel stops, we can compare them and see if they're true. All right, so probably that'll fix it. Let's try it now. So if I set that to 2, 2, and 2, yeah, there we go. Now I get a value of 2 because they're all the same. If I set them to one of them different, I'll get a value. Why am I getting a value of 2? I should not be getting a value of 2. Oh, because nothing gets triggered until the last one comes in is the reason why. Right? So if we're just testing this, and this will work fine when we're actually running the patch, but we're testing it right now. And when we test it, the thing that actually triggers the calculation is the last wheel that stops. So let's just add a button over here that we can use to test everything. All right, so we can bang this at any time and evaluate the current state of the wheels where they are. All right, so if I set this to 2, this one to 2, and this one to 3, what will my output be? 1. Why is it 1? because these two are true, but these two are not. So 1 plus 0 equals 1. They could also both be false, and then it should give me an output of 0. If I set this to 6, and now I can bang these, then what? Why am I getting a 1?
You're only banging the third one.
Oh, because I'm only banging the third one. Thank you. All right, patch these into all 3 numbers like that. And there we go. All right. So there's also probably some order of operations issues going on here too. But if you just hit the button a couple times, that will make it to where it is. And again, this should work fine if we just run the patch. Let's go ahead and just test it out. Click on the new game button, let it run through, and you probably won't win, but you should see a 0 at the other end when it's done if you don't win. You also see it change. We got to put that change object back in there again, because you see how it's flopping around, and sometimes it's true as the numbers are rolling past each other. It's true for a split second. We actually don't want to have these calculations done until last one stops, right? So what could we do for that? Well, how about instead of, let's see, what did I do before? Wow, yeah, this is kind of, all right. How about instead of passing these numbers through the logic operators the whole time, we have them gated off, and actually we can just store those numbers and then bang them out when the last gate closes, and then do all of our calculations at that time. So what we could do, let's see, we could store them in an int box, which is the non-graphical int, new object I, or you can type out int. These are helpful for storing a value and then outputting it when you get a bang. So patch those into the right inlet of these int objects. Okay, and then patch those into your logic operators. Oh, and let's see, we're doing that. I'm doing it wrong again. You want to cross patch this goes into the first number goes into the right inlet of that equals. Okay. All right, and then let's see right here. When this goes to 0, right? Then we want it to stop, or we want it to trigger when we want it to do its calculation when the clock stops. So let's see, when this gets to greater than 300 or whatever it is, it sends out a 0, and then we can select for that 0, I guess. Select 0. See if this works. And then send that bang to each of these int boxes. That should work. Let's try that again now. New game. So I should see a bang come out of this when the last one stops. Bang. Yeah. And that time we got the condition is 0. Okay. So let's see. We can test this now simply by sending a 0 up here to this cell 0. That will give us a bang. That should trigger our calculations. So this little 0 will be our way of testing things. So let's just trigger this to make sure that the true condition works. So I'm going to set them all as 2, and then I can click this, and I get a value of 2, and I got all the same triggering saying that I won for all the same, right? So I added this 0 over here, and that triggers things. So now we have all the same. What other conditions could we add to this as a winning condition? If we're just working with numbers, what would be something that you could say is an easy pattern to recognize? Anyone? Bueller? Come on. Ascending condition like 6, 7, 8? Or 7, 6, 5? How about doing that? All right, so anybody have an idea how we could use the same objects here to test that, but just do a little bit of math?
If input 1 minus input 2 equals 1,
Mm-hmm.
and input 2 minus input 3 equals 1, because then it would be
Yeah.
that would be descending.
Yeah. Let's see. So if you add them, wait.
If you take input 1 and subtract input 2 from it,
Input 2 from it.
and it's 1.
Mm-hmm. What if input 2 is 9 and input 1 is 1?
Well, then it would be negative 8.
Uh-huh.
So it wouldn't be 1.
Oh, right. I see. Okay. So if what if it's, okay, so if it's 5 and we're doing ascending, so, or we're doing descending, you're doing descending. So if it's 5 and then it's a 4, you subtract those 2 and you end up with a 1.
Mm-hmm.
So that could work. That's not the way I did it, but actually that's just as simple as the way I did it. The way I did it was simply you add 1 to the first number and subtract 1 from the last number, and that brings them all to the same, and then you ask it, are they all the same now?
Oh, yeah.
But what she did seems to work just as well. Let's try it. Let's try what you said. So we can leave this here as all the same, and all we need to do now to test our test this is subtract these two together. It's testing a descending condition. And again, we need to make sure we're doing this the right way so that it's triggering the calculation at the right time. So we want to, oh, wait a second though. We can't do that because then we would be subtracting A from B. So we need it to, we need it to trigger when the second number comes in, but subtract from the, wait.
We're still waiting.
Because, all right, so if I patch this in like this, well, here, actually, coming out of the int boxes, right? So if I patch it like this, the problem is that this calculation is going to trigger when the first number comes in. But if I patch it like this, then that's going to mess up the subtraction, right? Because subtraction's not commutative, the way addition is.
It'll just be negative when we're looking for better than 1.
Okay.
So for the ints the way they are they? They're all the ints are triggered at the same time.
Yes, technically, but really it's going to be this one first, and then this one, then that one. Yeah. So we could select for -1. The other thing we could do is this special subtract, which is the exclamation subtract, which is it's subtract. It's switch them around and subtract them is basically what it is. But you do this so that you can have something else trigger it, basically. Okay, so we do that for that, and then we have another one for the other two. So those are the first two. This would be actually here. Let's go. Let's before we, because this is starting to already become a spaghetti mess. Let's do this. Let's do sends and receives already. So let's say send wheel 1. Oh, all one word, no spaces. And duplicate that, make it a wheel 2. And duplicate that and make it a wheel 3. And let's patch those to the outputs of these int boxes. This way, when we go into multiple win conditions, we're not going to have spaghetti lines all over the place. And we might as well fix these up, fix this all the same up while we're at it, and use these receives. So let's see, that's the one we were working on. So we can just take this send wheel 1 and turn it into a receive wheel 1. And take this where it was coming out of the int box and just move it down to that. Receive wheel 2. All I'm doing is breaking these connections and putting them into the corresponding receive. Like that. Oh. Oh, that was wheel 2. So I can have that come over here like that. Does that make sense? So all I did so far is just get rid of those lines and make some sends and receives. And you're like, why would you bother doing that with things right next to each other? And that's because we're about to add extra win conditions, and it's going to get really messy. Now that I have these as sends and receives, I can move this anywhere in my patch, which is nice. So I can get this all out of the way, and now I have room to work on the next win condition. Which instead of using lines, let's use our sends and receives again. So just copy these receives. All right, so this comes in like that. Then we need that to trigger second to trigger the calculation. And one more of these, and you can pass that into the second inlet, and the first inlet's going to be wheel 3 because that triggers the calculation. And so then equals 1 is what Anna said. And equals 1. And add these together. Again, cross patch so that this one triggers, this here triggers the wheel 3 triggers the calculation. Okay, and you should have a 2. I'm going to patch it into a message so we can see, but I'm also going to patch it into a select 2 to give yourself some extra margin space. Oh, I already have some. But if you find that you can't scroll down for some reason, you can give yourself extra margin space by making a comment and just dragging it off the screen below you and moving it down. It's kind of a workaround. Great. So then cell 2, bang. This would be descending win. All right, let's test that out. So I have a 3, a 2, and a 1, and then I click the 0. Remember, here's what we had this that we can use to test. Why did I end up with a 0? Well, what happened there?
Well, right now it doesn't work because it's the
One,
2.
that gave me a
We're
1.
subtracting 1 from 2 and 2 from 3, so really it would only work.
So that's getting 1. Wait, but these both were 1. And that gave me a 2. Why did that not win? It did win. Something probably happened with the... Let me try it again. So let's see. 5, 4, and 3. All right, and then we click this to do our calculations. Oh, for some reason I am getting a negative on this. Why? Because I'm saying maybe this wants to be a regular minus. Maybe that's what the problem is. Let's see. 6, 5, 4. Bang. No, because that gave me a 4 on the output, so that didn't work. Why did that give me a negative number? And it gave me a negative. Might have to go back to the way I know how to do it just because I know it works. I mean, you're obviously your method makes sense. There's something I'm doing wrong in the patching here that's breaking it. And I think it has to do with order of operations. And why do I get a negative 2? Because 3 minus 7 is negative 2, right? Is that what it is? 3 minus 3. Negative 4. All right. Wheel 3. Do I have a typo in my sends and receives? No. Yeah, that gives me a negative 4. Oh, wait, that's what it should be. Okay, so 3, 2, and 1. Trigger. And why do I get a 2? That doesn't make sense to me. Because 2 minus 1 should be a 1, or 1 minus 2 should be a negative 1. I don't know why I'm getting a 2 there.
Well, because right now you're getting a 2. Well, that will always give you.
It must be there's something left over in this that didn't get updated when it triggered the calculation.
That's possible. Are your sends all aligned?
Yeah, I'm wondering if that's it. Let's see. Maybe it's that the wheel 2 was a little bit lower, and it was an order of operations thing. So 5, 6, 7. This should be a win. No, why a negative 3? And then it works the second time. So there's definitely an order of operations thing going on here. Oh, crap. I hate that. So when I have that problem, what I usually do is I just work around it by like setting a specific order of operations through triggers. Okay, let's see. So instead of banging all these at the same time like we're doing, we bang them one at a time so that way we know exactly the output order.
Do you have to bang it twice to get it to send?
No. So instead of going straight down to all these, what we should do is do a trigger bang, bang, bang. TBBB. T is short for trigger, and you can use trigger to trigger whatever you want. It can be a message, it can be a number, it can be a bang. And you can shortcut the word bang with a B. You can shortcut integers with an I, stuff like that. If you have trigger int or trigger float or trigger list, then it will trigger whatever the input integer that you sent into it was, or the list that you sent into it was. All right, so what we can do with this is it'll tell you what the output order is, and this is the first one. So we want this to go to the first int box, so that it will always output first. This one will always output second. This one will always output last. See if this solves our issue. Seven, 6, 5, 3, 2, 1. Yes, that fixed it. All right, so that solved that issue. Yeah, there was some problem, probably having to do it. So if you don't specify an order of operations, your order of operations is specified for you based on the graphical position of objects on the screen, going from bottom to top first and right to left first and bottom to top second, I think, which can be really confusing. So when you can get around that by using triggers, do it. It just will save you a lot of headache in the long run. All right, so that works. So if we wanted this to be ascending, we could do the same thing, but change this calculation, right? So what do we do for ascending? I think we can use the regular minus. So if all right, so right now it's this one minus this one equals 1. If we want it to go the other way, we need this one minus this one equals 1. Right? Yeah. So that's fine. We just use the regular minus. And same here. Should that work? Let's see. 2, 3, 4. Oh, this would be ascending. 2, 3, 4, and test that. Hey, it works, because it ends up with a -1 over on this side and a +1 over on this side. So that works. Great. Cool. So now we have 3 different win conditions. We could go for one more. What would it be? There's always a jackpot, right? And if we're going to use numbers, what would our jackpot be?
999.
9s? What's wrong?
666.
6s? Jeez. Sign of the devil. Most people go for lucky 7s, but okay, let's do 6s. All right. All 6s. So anybody have an idea how we could do all 6s? Well, we could do what we did over here with 1s, where we said equals 1, and we could say, we could ask if every single one equals 6, and then add them together and then test for what, an output of 3. But we don't really need to do that. All we really need to do is if this one, if the output is equals to 2, then they're all the same. We could add a third category that says, is the third wheel equal to 7? Because then if A is equal to B, B is equal to C, and C is equal to 7, we know they're all 7. And we can add these together. That always triggers last. So we want that to come in and then this to come over here. And select for 3. And then we have all 6s. All right, let's test that out. So let's make this 777 first. And then trigger the calculation. And I got all the same, but I did not get all 6s until I hit it a second time. Why? So something went bad there. Oh, wait, why did that change to 7? Oh, because I did 7, but because I said all 7s, I messed up. I'm so used to lucky 7s. This was supposed to be a 6. All right, so all 7s. If I click this, I get all the same win, but I don't get all 6 win if I change this to 6s. Then I get all the same and all 6s. Is that working for everybody? Cool. All right. I said I'd show you scale. Let me just show you scale. I don't know how to work this into anything, but let's just look at scale. So if you have a float and you want that to scale to a different range of numbers, so take 2 float objects. You can have a new object scale. You can scale one to another by saying that the arguments are the input low, the input high, the output low, and the output high. You just construct that kind of as a sentence. You say, I'm scaling 0 period to 10 period, and I want to scale that to the range 40 to 50 in integers. And then say this was not an float, say that was an integer box. You can see then it will automatically scale this for you. And it goes past those ranges. Like if I go, it figures out what that ratio is and will interpolate beyond, before and after that range that you set. Okay? Oftentimes you're doing this the other way though. You're going to be taking a integer range and mapping it to a float range. So like the more common one you might see is 0 to 2, scale 0 to 255, 0 to 55 between 0 and 1. That's a really common one that you'd see. So you'd want this to be a float over here. And doesn't matter that that's a thing. So now 255 is 1, as you can see, and 0 is 0. And so it scales that number for you. So you'll use this scale object a lot to make different number ranges fall into each other. I'm just going to delete that because it doesn't really have to do with this patch at all. This R test I don't think does anything. Oh wait, we were just playing around with sends and receives. Let's get rid of that too. All right, let's stop here and we'll do the payouts and the money system next class, and we'll add graphics and stuff. There's a pretty easy way that we can use these numbers to, instead of trigger numbers, trigger pictures of fruit and stuff on the screen to make it look like a real slot machine. All right, so save this and we'll work on it some more next time. Let's continue on with our candy patch from last class. So I think it was called Sweethearts. So yeah, so far we have these candies in a patcher, an external patcher here. They're being fed bangs to make the messages translate. And actually that system was not working on Sai's computer, and we couldn't figure out why. We chalked it up to some difference in Windows and Mac, between Windows and Macs. I'm not exactly sure why hers didn't work. but I found a different way of doing it, and I decided that the way that I figured out is the better way of doing it. So I want to go back and change our patch to match that. It actually simplifies things quite a bit. And because we're using external patchers, this change should be fairly simple and won't affect what we have patched here. At least won't affect it, it won't break it. All right, so we'll go open up your sub patch for the candy patch, right? So right now we have a fizz body, and we have that attached to the model that's holding the actual conversation heart 3D model. And then we're polling get state from that fizz body to get its position, and we're sending that get its position and its rotation, and we're sending that position and rotation to this text every single frame to update where that text should be and how it should rotate. There's a better way of doing this to simply lock everything together, all our different 3D stuff, as one kind of physical object to create what's called a hierarchical rendering group, and then just attach all of that to a single fizz body, and then you don't have to poll the fizz body for anything. So this is something I kind of knew how to do, but kind of forgot about until last week. So there is a thing called jit.anim.node, which says perform hierarchical transformation. And what you can do is, instead of attaching this model to the fizz body, let's just break this connection. We're going to have a two-tiered hierarchical rendering group. First, we're going to have a node that's attached to the conversation heart. And we don't need this anymore. We don't need route pass position. We don't need rotate XYZ. We don't need any of this message stuff. Okay. We probably want to keep this inlet. We won't need this get state or this inlet. Okay, so we attach this to the anim node to the conversation model heart. Then we have another subnode, so duplicate this anim node. And we attach this to the GL text 3D. And everything in here that has to do with its position and size, we need to actually move from the text 3D up to the anim node. So take the scale and the anchor. Take those out of this. So I just highlighted them and cut them, and then I'm going to paste them in the anim node, because that's what actually takes over control of those attributes when you attach it to an object. And now you can attach this node to this node, so that this is the main node and this is the child node underneath it. Does that make sense? And now all we have to do is attach the body to this main parent node, and now everything should be glued together. I think there's one other thing, and that's that the text probably... Now go ahead and save this. And now all your candy, I think all the text fell off of it. I saw it roll by the screen. And that was because... well, first of all, I'm pretty sure there's a rotate in here that we need to get. Because I remember we were transforming the rotate by 90 degrees. So in the anim node, add an @rotate XYZ -90 0 0. Is there anything else? Oh, did I get scale? No, I got scale in there. Okay. And save that. Why do I see? There we go. And now it's working right. And see, now all the text is it's just glued on there, and we don't have to worry about messages or anything. Is that working? Yeah, yeah, there. Are you guys all with me? Does anybody need more time on this? How you doing, Charlotte? Okay, whoa, what's that? Well, that's a little weird. I do see an extra. That's probably. Is it still sending messages around? Oh, those are the other candy heart things. Okay. Save. I think. Do I have two patches open? Do you guys have extra little text flying around? I noticed mine had some extra text there. And it's on the heart, but it's also over here on this side. Do you guys have that? Does anybody have that on theirs? It might be because I had another patch open and something's confused. Let me try just saving, closing, and reopening mine. Save. Save. Do I have anything else? I do not have anything else open. Okay, reopen. Oh, that's the old patch. Sweetheart. Yeah, no, that's the right patch. Okay. Oh, also this now, we don't need that attached. Get rid of these. These shouldn't, these connections shouldn't do anything. Maybe it was throwing it off. The connections coming out of the render bang into the candy. Well, we actually want to, we're keeping that inlet so that we can, if we want to, we can have, we can change the text on the heart just by simply attaching this to it. Okay, let me turn it on. I think maybe that fixed it. I don't see any text flying around anymore. Okay, good. That did fix it. Cool. So if I want to now, I still have this inlet that if you patch this text edit object in there, it will send the message necessary for that text 3D to display a different message. So I could say, "Hi, Mom." Hit enter, and there you go. Now this one says, "Hi, Mom." Okay. There's a better way we could do that, and that is to use patcher arguments. And it's also how we can easily instantiate each of these objects with not only an individual message, but we can have each of them have their own color and whatever other attributes that we want to have affected. And you do that by using a thing called patcher arguments. So patcher arguments are a way of passing along info from your instantiation of that object. So you can, in the file, so open up the Candy subpatcher file and unlock your patcher. There we go. So I can simply, any piece of text that I want to have change based on patcher arguments, I can replace with a #1 through #9. So in this case, the message, this is where we are setting the message, right? Text, love you. Instead of text, love you, I can say text #1. That #1, just like a $1, will get replaced with what I put in the patcher argument, okay? Text #1. What else do we want to be able to have independent? Color. So I can say color hash 2 through, wait, this is the text. Actually, let's leave the text color alone because I think sweethearts always are printed in red. So I meant this color up here, actually. This color here, we can say hash 2, 3, and 4. Hash 2, hash 3, hash 4. Okay, and is that all? Yeah, that's it for now. Save this. And now you can close it. And now you can come back to your Candy Patch and you can instantiate this with a message. So the first argument you put in here is going to be your hash 1, which was your message. If you want that message to have a space in it, you're going to have to use quotation marks on either side. Then the second will be the R value for the color, the third will be the G value, and the fourth will be the blue value. So if we want this to be hi mom, I can say quote hi mom, end quote, and now I can put the color. Let's see, let's make it a green, a pastel green. So like 0.8, 1, 0.8. And now you see I have a green Hi Mom candy that's a pastel green. And I can make as many of these as I want now and make each one different. I can say this one's not Hi Mom, this one is Eat Me. And let's make it bluish instead of greenish. 0.8 and a 1 on the blue channel. And now I have a purplish blue Eat Me. Okay. Let's see, what else? Oh, so that's cool. Sometimes maybe you want a special candy that has a bit longer text, and you need to have special, like you need to adjust that anchor point and so forth to get your text to be in the right spot. We can go one step further in our subpatcher files. So open up the Candy Patch again. And we can use hash values like we did here. That'll get replaced by our patcher arguments. We can also use attributes instead of arguments. There's an object called patcher arguments, patcher args, and this output will give you the list of normal arguments. We don't need that because we're using the hash tags instead. This second outlet will give you attribute arguments. So anything that you put in that with an @ symbol, it'll pass that @ symbol along out this second outlet. We can pass that to the text 3D because that should be the only thing that we'll need to do special attribute arguments to. And I think you don't get these until a bang triggers them. So we're going to want a load bang here to trigger these patcher args on instantiation of the object like that. And save this. And now we've opened up anything that we want to send attribute-wise to that thing. You have to go, Charlotte?
No, I'm sorry.
Oh, okay. That's all right. Okay, so let's try a longer message. This is, instead of hi mom, let's say this is, I don't know. Hello world. Classic programmer text. So say we want to make this hello world, we want to change where that is on the candy because it looks a little low right now. So I can say @anchor we need to move it down on the Y scale. So 0, 0.3, try 0.3. What is wrong with my, there we go. And then I think you had to have 0.37 on the Z scale to make it be above the surface of the candy. And now you can see it's moved it. It's slightly. If I made this 0.9, you would move it even more. Or I could even say 3. Is that not moving it? Wait, what is this? Oh, maybe this is the, what is this? I have an extra, is that this candy? Oh.
Not that one.
This one. That's why. Okay. I see. That's why it's black. Why is it black? Because if we don't supply a patcher argument, that will be moved in with. I mean, it'll give you a 0 instead. So its color is 0, 0, 0. So it's black. Oh, so let's make this one white. Oh, whoops. I forgot. The first one is the text. Hi. 1, 1, 1. There we go. There's our hello world with the you can see that you can definitely see that the anchor position was passed along because now my hello world is right off of the candy. Right? So I can say 0.76 or something, 0.5. There. And that made it a little bit higher up than it was before. All right. So that's cool. What else can we do? We got that. Oh, I showed you how you can use this input to make custom text. So if you wanted to have a user input put in their own text on the heart, you have that option. We did the attributes. Okay, let's look at some keyboard controls. How to work with some keyboard controls. So in the homework, we had you analyze a number stream either coming from the mouse or from a line object or from whatever. You probably use either equals equals or a greater than or a less than. This time we're going to use an equals equals. And what we're going to do is we're going to test to see if one of the modifier keys are being pushed by the keyboard. So we need a key object to see what buttons are being pushed. And what I propose to do is have a system that turns on and turns off the fizz draw, so we can turn off these physics boxes that we don't necessarily want to see. So if you look at the outputs on the key, the first one is the ASCII code of the key press. The second one is platform specific. Those are different based on whether you're on Mac or Windows. The third one is the modifier. That should be the same whether you're on either platform. So attach a message or a number box to this third input and type like a shift something, shift C. Lock your patcher. Oh, whoops, I deleted my connection. Third outlet, modifiers. Lock your patcher, shift, and hit something. You see it gives me a 512. Doesn't matter what key I'm hitting, as long as I'm holding down shift. If I hold down control, which is another modifier, and push a key, it'll give me a different one, like 4096. Shift 3, I get a 512, right? So we can say, is this 512? And if it is, then that will be a 1. What can we do with that 1? What did we do in the slot machine? We used it to control a gate. So if it's 512, this will be a 1, which will open the gate and allow the actual key that you press to go through the gate. If it's not, if you're not holding the shift, it won't go through the gate. And then you can just decide what you want to select for. So say for this debug mode, let's make it a D. So what comes through when you press a D? Well, If I have that patched up and I press a D, nothing comes through because I'm not hitting shift. But as soon as I hit shift and I hit D, now it's passing that through and it's 68. And if I hold down shift and hit a different key, it should be a different number. Okay, so we want 68, so we can select for 68. So now when you hit shift D, this will have a bang that should light up. Yeah, and if I hit something else, it doesn't. See, shift K doesn't do anything, but shift D does. All right. Cool. So now we can send this to the FizzDraw enable thing up here. So let's just move this code up here, or I can move my FizzDraw stuff down a little bit and put this stuff on top of it. And we can pass this into the toggle, and what we can do is shift D will turn this on and off. So shift D turns it on, shift D turns it off. And if I'm full screen, I can now at any time I want go into debug mode. Okay. Yeah. Okay. All right. So now the other thing I wanted to do with this was reset the camera, because sometimes your camera gets all wonky and you don't know where it is, and you don't know, because sometimes you'll be looking like straight down and you're trying to rotate and you're like, what's going on? So we can reset the camera just by sending it back to this position 0010. We can make it go back to that position by sending it a message, position 0010. Let's just copy it right out of this here. Just grab this text, position 0010, copy, paste it into a message. And we can add another select over here. What do we want for camera? Let's use C, right? So what's shift C? So coming out of the gate here, if I make sure you lock your patcher, because C is going to want to give you a comment. Otherwise, shift C, 67. Oh, great. So it's just one less. So I can say select 68. I can also say add 67. I can add as many arguments to this select as I want. Each time it'll add another output. That will be when this matches 67, that will bang. So I can send that to this camera position message and send that to the camera. And so now anytime I want, I can say shift C and reset my camera. Okay. Let's see what else. Okay. Let's look at how we could do like a secret combination. Like you hit 4 keys in this order and that triggers something, unlocks something. We're going to use the key object again. And yes.
I have a question.
Yeah.
Can you just remind me, the equals 512, why do we need that at the beginning?
That is what is selecting for the shift modifier.
Shift, okay, that's it.
Yeah. So, and you can figure out what that is. So like if you didn't know that it's 512, you just attach a blank message to this and then hit shift, and, or if you wanted it to be control, hit control and hit a letter or a number or something, and that's the number you want to select for. So if I wanted it to be control, I could say equals 4096, right? All right. So to do like a 4 combination thing, there's different ways we could do this. We could use a series of gates. I found a simplified way of using an object called cycle. Which cycle, what it does is as it gets numbers into it, it'll output it sequentially out of its outputs. So let's make this a 4-digit combination. And so just patch that right into the cycle. And then we can do equals equals and then the numbers that we want to match for. But again, remember, these numbers that will be coming out are the ASCII value, not the actual number. So like if I want this to be a number key, if I hit the number 1, that's a 49 in ASCII. 2 is 50. 3 is 51. 4 is 52. Actually, let's just use those. Let's do 1, 2, 3, 4. It's the stupidest combination ever. I got the same one on my luggage. All right. So what was it? Is it? I think it was 49, wasn't it? 49 through 52. 49, 50, 51, and 52. And because we need these to all get hit in the right order, as soon as any of them equals 0, you got to go back to the beginning and start over. And it basically resets everything to 0. So we just need a select 0, and we can patch every single output of these into that select 0. Because if any of them ever hit 0, that means you got the combination wrong. So select 0. Patch every single one of these into the select 0. And so if that's the case, then you want to send a 0. No. For now, you want this to go back to cycle to go back to 0, its first output, which is you can send a message called set and then the number, set the next outlet. So set the next outlet as 0. So if any of those trigger, it goes into that cycle and sets it back to 0, and so you go back to the first outlet. We need to patch these into these. We forgot to do this. Like that. There we go. Okay, and there's something else that we got to do, and that is 0 anything. So we're going to store these numbers as they come in. We can store them just in an integer box. Four integer boxes. They can be the graphical version. They don't have to be the non-graphical version. And what we can do is if any of these, if this triggers 0, we have this reset everything, all of these numbers to 0. So that way, those get reset. If any of if you ever get it wrong, all of them will reset back to 0. Then what do we need to do? So if none of them, if you got them all right in the right order, these should all be 1, right? And then, so then what do? We add them together and select for 4, right? So let's do that. We could do a series of plus objects. I'm going to show you another way of doing this, and that is to pack it into a list, POC. And you want it to be a POC so that it will trigger if any of the inputs change. And there's a special object called ZL, which does all kinds of different list processing. And one of the sub-functions of ZL is sum. You have to, the ZL objects have their own syntax. You say ZL and then what you want it to do, whether you want to be ZL sum, you can say ZL sum, or you can see ZL dot sum or dot slice or whatever. We'll look at the ZL objects at various times. It's kind of strange that they don't just fold these into regular objects, and I don't know why they still call them ZL. They should just fold them into regular objects because you'll use these all the time. They have a lot better, more involved. They have additional functions in list processing that you can't get in any other Max object, and you'll find them very useful. Sum is one of the ones I use the most. So all this does is add all of the numbers, and it only works with numbers. As long as your list is consisting of numbers, it will add all those numbers together and give you the sum. So it's a really easy way to add these together and get 4. And so now we select for 4. Equals 4 and select for 1, or I could just select for 4, right? Yeah, that should work. Well, I did it this way in my notes, and I've already screwed myself over by not sticking to my notes. So let's just stick to my notes. Equals 4, and then select for 1. I think you might just be able to select for 4 instead of doing this. But let's try it this way. If someone wants to try just selecting for 4, go for it and tell me whether it works. And then, so if this is, they all triggered, then that's great. Then you've unlocked it. So we can send this to, whoops, a send combo. So let's try this out. Just attach it to a button for now. And I go 1, you see that goes, it changes to 1. 2, the second one changes to 1 because it's true. 3 changes to 1, and 4, boom, right? And now let's try it again. This time I'm going to go 1, that worked. Okay, so first of all, now once we win once, so that's a bug. Once we win once, as long as I hit 1, 2, 3, 4, it'll re-trigger. No, as long as I keep hitting. Yeah, so as long as I keep hitting 1, 2, 3, 4, it'll keep re-triggering. We don't want it to do that. We want, as soon as you win, to reset everything as well, right? So we can send to the combo and receive the combo up here to re-zero all this stuff out. Re 4, and now it re-zeroes it out. 1, 2, 3, 4. Now see, I'm still getting a bug because I still get a re-trigger the first time I get a 1. So I think I could fix that by doing a change. Come on, unlock. There we go. So just here doing a change. That makes sure that you never get two in a row. That'll probably work. Let's see. Oh, but now see, that broke it because now it should be, it's, ugh. All right, so that doesn't work. Because we want it to continue to win more than once. So I don't know why I was getting that triggering every time. See, every time I hit 1 now, it's working. So how do I fix that? So what's going on? Because those all equal to 4. And the cycle, okay. So as soon as, I know how to fix this. As soon as this goes to anything, this should be a 0 on everything. On the others. Okay. Jeez. 0. This got a little more complicated than I thought. All right, so as soon as this first outlet triggers, we want it to 0 everything else out. We already have a 0 here. Maybe that's all we need to do. This should 0 everything. Is that? No, but that's not going to work because that's, oh, for the love of Pete. All right, whatever. I'm going to give up on this bug for now. It's not that big of a deal. I'll come up with a better solution next time. Let's leave it alone for now because I want to continue on. I don't want to waste time trying to figure out this little, it's not even that big of a bug. It's just if you keep hitting 1 after you've solved the combination, it'll keep triggering, but it's not that big a deal. For now, I'll fix it later. Okay, so we have this combination. It triggers when we hit 1, 2, 3, 4. Great. There is a little bug involved there. If I keep hitting 1 after that, it'll keep triggering, but that's neither here nor there. Let's use this to affect gravity. So like when you hit the combination, it turns off gravity, and then you can make things fly around. So on this trigger, we can send this to a gravity message up here. So we can say receive combo. So we don't have to have patch cords going a really long way. And send this to the gravity message. And actually, we want this to, we're gonna make this be a toggle. So actually, let's send it to a button. Or is it already a button? I think it is already a bang. Yeah, it is a bang. So just send it to a toggle. And then we'll say cell 1, cell 0 and cell 0 and 1. And when it's 0, it will set the gravity to 0. And when it's 1, let's duplicate this gravity message. Change the y value to negative 9.8, which is the Earth's gravity, negative 9.8 meters per second per second. And pass that in there. So now when it's it'll either turn the gravity on or turn the gravity off. So the gravity is now off. I can fling these around, and if I trigger the combination, 1, 2, 3, 4, the gravity goes on and they all fall. Did you see that? So 1, 2, 3, 4, gravity's off. I can fling them around. I got 0 gravity. And 1, 2, 3, 4, boom, everything turns on. Okay? Let's add some feedback so that we know what happened. So go to, we're going to add some JIT-GL text. JIT-GL text 2D, actually, because we just want it to stay on the screen. And text 2D will always give you a raster text. Doesn't matter which way the camera is facing. It'll always just put two-dimensional text on the screen. Let's make the text white at color 1, 1, 1, 1, 4 ones. At font size, and you can grab it. You can start to type it and then click it out of the list. Say 40. That's nice and big. At align 1, that makes it centered. And yeah, that's good enough for now. Then we're going to want it to say gravity on or gravity off, right? So we know we want it to say gravity. We need it to say text and then gravity and then either on or off. So we could have a bunch of different messages and just send those to it. And that's totally fine and probably easier, but I want to show you guys how you can use appends and prepends to construct a message that can change based on input or based on conditions. So we can start with the word gravity because that's never going to change. And let's make these all caps so that it will be nice and bold on the screen. Gravity. That part of the message won't change. But we'll need to add to that either the word on or off. We could do that with append on or append off. We don't know what they're going to be yet, so we're just going to be an append. We're not going to specify what it's appending yet. We'll need to then after that so after we append the word on or append the word off, we'll have gravity on or gravity off. But we need the message to be text gravity on or text gravity off for the JIT-GL text 2D object to understand it. So the other object like append, is prepend, which adds, append adds something after a message, prepend adds it before. So we can prepend the word text to this. So gravity goes into append, and then out of the append into prepend text, and then out of the prepend text to the text2D object. Okay, and so now if you click this, it should just say gravity because it didn't append anything because we haven't set anything for the append to append anything yet. All right, so to add something to that append, we have to send the message set and then what we want it to append. So we want it to be set and then either on or off. So we have the combo triggering things. So let's receive this combo again. And then we want to have that go into a toggle. And then we can select for one, just need to select for one. This is either going to be 0 or 1. We probably, actually, we could have done this up here too. I think it's easier because of buttons, but whatever. So if this is only going to ever be 0 or 1. So if it's a 1, it's going to come out this outlet and it'll be a bang. If it's a 0, it'll come out this outlet and it won't be a bang. It'll just be whatever the input value was. They make it that way so that you can chain a bunch of selects together or other objects that work the same way. You can chain them together, and if it doesn't match this, then you just pass it along down the chain. In our case, we're just going to use triggers, and so it doesn't matter whether it's a bang or anything because we're triggering something. We're going to trigger the word off, and we're going to trigger the word on. And again, triggers can trigger anything. It can be a word, it can be the word anything, it can be a bang, it can be an integer. Whatever you want to trigger, you can do it. So that one's going to trigger the word on, that one's going to trigger the word off. We pass this into a message that is set $1. That way it'll create the message set on or set off, and we pass that to the append. So now the append will know what to append. Okay? Then that should do it. So let's try that out. So go type the combo 1, 2, 3, 4. Try it again 1, 2, 3, 4. Why didn't it work? Because I never triggered gravity is why. Because this gravity is what actually sets everything into motion. So this combo should trigger the word gravity. So what we actually, and we need to do this in the right order because we need to make sure that the append gets its argument before we trigger the word gravity. We can do that with a simple trigger here. Trigger bang list, TBL. Right? The word, whoops, something happened here. Yeah, you're right. They should both be going into the left inlet here, not the right inlet. All right, so we have this set $1, that's a list, right? Any message that's consisting of more than one word is a list. Even a message consisting of one word is a list. It's just a one-item list. So this will first output the list and then output a bang, second order bang. So the list goes to the append. Get rid of that one. And then the second thing that happens, the bang goes to this gravity to actually trigger that action. Okay, and to make this clear, you want to keep things that are going to different places on different levels. That way it's clear where the lines go. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Gravity on. 1, 2, 3, 4. Gravity off. 2, 3, 4. Gravity on. Do I have it backwards? No, I got it right. 1, 2, 3, 4. Gravity off. And now I can flick things around and they don't fall. a few more minutes. One thing I think we should do is have this gravity off flash and go away after a couple seconds. We can do that with an enable message that gets triggered by the text itself. So coming into this prepend text, we can use this to do a trigger. We can have this trigger 0, 1, and list. And myself some margin space. Oh, come on. It's not even letting me throw my comment down. Sorry, Max is fighting me right now. There we go. Okay. All right, so what we can do, break this connection and instead have it do this through a list. And the 0 and 1 will enable it and disable it. So first it sends the text, then it will send a message that will enable $1. So this 1 comes out second and enables that text object, and then we can have this one disable it. But if we just connected like that, it would enable it and immediately disable it, and you probably wouldn't see it. So we want it to enable it and then wait like a second and then disable it. So you can delay this 0 coming into the message to do that. Is a simple way of doing that. There's two different delay objects. One is called delay, and that's the one you would think to use. But delay will only delay bangs. It's annoying. There's another object that will delay everything else, and it's called pipe. I don't know. They should switch them around and make the weird one the least useful. But it's called pipe. So if we wanted this to be like 2 seconds, I could say pipe 2000. That's 2000 milliseconds. And that will delay this 0 by 2000 milliseconds. And then I can send that into the enable to then disable 2 seconds after the text. So let's try this out. 1, 2, 3, 4, gravity on, and 2 seconds later, boom, it goes away. 1, 2, 3, 4, gravity off, boom. 2, 3, 4, gravity on. Oh, that's that bug where it's double triggering that 1. Whatever. I'll fix that. I don't know what's causing that. All right, so this happens sometimes. My heart's disappeared. I can fix that by turning the world box on and off and back on again. That should force the hearts back. Nope. If that didn't, you can just delete your candies and undo. That should put them back. Mine lost all their color. I must have some Max issues. Where's my Max window? Oh, yeah. So now I got, what do I have? Text 3D doesn't understand done. Who's sending it done? Text 3D. Whatever. That's from the sub patch. Somehow mine are getting a word done. Yeah, that can happen. And you see, is it yellow? That's usually just a bug. And you should, if you save and reopen or you delete them and reinstantiate them, it'll fix that. Great. We're out of time. It's 2:50. That was pretty much all I wanted to show you. I did mention this one other thing. Let's just do that, and it'll only take 5 seconds. You downloaded that video off of the website with the hearts. Yeah, drag that onto your patcher. It's like red and white hearts background thing. And you want a JIT gl.video plane. And you can say on this, you can say at transform reset 2, which will override any camera stuff and simply display the image stretched to fill the entire screen, no matter what your aspect ratio is. And the problem is now we have a layering issue because we instantiated this last, and so it's on top of everything. So we can, first of all, we can get rid of that by doing at depth enable 0. Whoops, that's the wrong object, sorry. This one. At depth enable 0 and specifying a layer at layer 0. And that will put it behind anything with a higher layer. If you now have, what the hell is going on with my camera? Oh, caps lock got turned on, that's why. Yeah, my colors got, oh no, there they are. That's all that happened. I was upside down, so the light was on the other side. Okay. And so now, if you have something weird where sometimes the other things, either like the fizz draw lines look kind of like they're missing and stuff, you can specify other layer messages. Like here in the fizz draw, you'd probably want fizz draw to be the highest layer because you want that to be on top of everything at layer 5. And see, now I've lost my candies and stuff. So I'd have to go into the candy patch and give them layers as well. Candy, and I can say at layer 2, and the text would be at layer 3. And now you can see now we have specified layer ordering as well. And you can see that video thing completely ignores the 3D camera, and it simply just glues a picture in the background. So this is another way of making a background without using a skybox like we've done so far, right? Okay, that's all really for today. There was one other thing I was going to do, which was this combination. I was going to add a ghost force that just simply made everything clump into the middle, and when you when you turn gravity on, that ghost force usually isn't enough to lift them off the ground, so you won't even see it. But then when you turn gravity off, they'll float off the ground toward the ghost force to make it obvious that gravity is off. That was the only thing I didn't do. Let's see. For your homework, I want you to do some more things. I want you to do basically like you did last time, some sort of patch that you're triggering things based on conditions, but this time it needs to be that more than one condition are met at the same time. So like we did in the with the slot machine, trigger for based on at least 2 conditions being met. Okay? And just do something cool. You can continue and make what you worked on last week even cooler, or you can make a brand new patch.